Alrighty, hello everybody and welcome to your pre-lesson video today on imaginary and complex numbers. So to get started off, we're just going to go over the definitions of what an imaginary number is and what a complex number is, alright? Really quick. So an imaginary number essentially is a number that doesn't exist, and we will denote it using the symbol I, alright, for imaginary. And only this happens when you are square rooting a negative number, and I'll get into that in a second. And so I would also equal to square root of -1. Now, if you were to ever, square root a negative number in your calculator, you would actually get a math error just because um, square root of a negative number does not exist. It is an imaginary number. All right, so I equals the square root -1. Now, if we were to square it, so like I squared, we know we will get a value of -1. All right, and we'll actually see this in a second when we get into powers of I. All right, now, like I say, the reason that we denote an imaginary number as I is because a square root can only be of a positive number, right? So that means a square root of a negative number just isn't possible. But yet sometimes we do have that in our equations. And what that means is that we have an imaginary number, and hence we would denote that as I. All right? Now, a complex number, it includes the imaginary number I in the form of A plus BI, right? So this is the standard form for a complex number. Now, an example of how you write a complex number is like 3 plus 2i, right? 3 being the real number and 2i being the imaginary number. Could also be like -4 minus 6i. -4 is the real number and a -6i will be the imaginary number. All right, so I will repeat. A complex number is just an imaginary number written in the standard form a plus bi. All right. Now, onto powers of I. It is really useful to remember what the powers of I are, because in a second you'll actually see that it goes in a pattern. So like we said before, I to the power of 1, so I itself, equals to -1, right? Now I square, if you break it down, is I times I, which means it's -1 times -1, which we also know is equal to -1 if we were to, multiply this. All right, so I square equals to -1. Now, I cube, if we break it down, it can be written as I squared times I, right? And we know from before, I square is -1 and I is square root of -1. Now, if we multiply this together, we would get negative square root -1, or you could also rewrite it as just -I. All right. Now, I to the power of 4 can be broken down into I square times I square. All right, which means we have -1 times -1, which we know would equal to +1. All right, so as you can see here, I'll just write aside. I is -1. I square is, I is square root of -1. I square is -1. I cube is -I. And I to the power of 4 is 1. Now, if we look at the bottom here, let's take I5. Now, if we break that down, we get I4 times I, right? And from here, we know I4 is 1 times square root of -1. And from here, this will give us I. Okay? And now we know also I is equivalent to square root -1. Now let's look at I6. So it's like I4 times I square. So it's 1 times -1, which would give us -1. Can you see the pattern? Now if we were to do I7, I know in the end it's going to give me -I, and then I8 is going to give me 1. Now as you can see, it's a repeating pattern, right? So if you can find the pattern, you'll be able to, even if the power is super big, like here, super big, if you can find the pattern, you'll be able to find the answer just basing it off this, because it is a pattern. All right. If you have any questions about this, bring it to your deep dive lesson. All right. Now using the powers of I, let's try to solve some questions. So for here, we would want to multiply the real numbers with the real numbers and the imaginary number by the imaginary number. So if we were to break this down, we have 5 times 5 times I, right? And then from here, we know 5 times 5 is 25. And then I times I is going to give us I squared. Now we're not done yet because we know the value of I squared. So we have 25 times, we're going to replace I squared with -1. Can you see that? Now from here, my final answer is going to be -25. All right. So whenever you're doing equations or expressions with imaginary numbers, remember the powers and simplify it as much as you can. All right. So now let's look at the bottom one. You have 2I times -3I. So let's group it together. So we have 2 times -3 times I times I. -2 times -3 is -6. I and I is going to be I squared. All right. Now from here, this is going to give us -6 times -1, which would then give us a final answer, 6. All right. Now let's see, whenever we are multiplying with radicals, the first thing we would want to do is if the number inside the radical has a negative, we want to take out the negative sign first and give it an I, right? So in this case, the first thing we need to do is take out the negative. So we get I square root 16 times I square root 25. All right, and then from here, we actually know that we can square root 16 and square root 25. So from here, it's going to give us 4I times 5I, right? Now we can multiply it together. So 4 times 5 is 20, and then I times I is going to give us I squared. Again, we know what I squared can be, right? So we have 20 times -1, which would give us the final answer of 20. All right. Now let's look at the bottom one. So again, if inside the radical sign there is a negative number, take out the negative number and denote it as I. So we have I to the power of, I square root 10 times square root 5. Now I don't need to put a I in front of square root 5 because 5 was a positive number. All right. Now from here, if you remember how to multiply with radicals, we would multiply the numbers inside. So we're going to get I square root 50. Now from here, I know that 50 can be simplified further. So let's do the tree. Let's see, let's take 25 and 2. These can be broken down. Okay. That means 5 will be outside. So it will be 5I, and then since 2 wasn't repeated twice, it will still be in a square root. So that means my final answer is going to be 5I square root 2. All right. If you have any questions about this, bring it to your deep dive lesson. Now, with complex numbers, you can add, subtract, multiply, or divide complex numbers like usual. Here are a few rules. To add or subtract complex numbers, you have to add or subtract the real parts first, and then add or subtract the imaginary parts. So imagine the I like a variable, right? If it doesn't have an I, it's a different species from the real numbers, okay? So you, again, like before, you want to group the same species together. And that's for addition and subtraction. Now, to multiply complex numbers, you have to treat them as a binomial and use FOIL, right? And then to simplify the product, use the definition of I squared equals negative 1, or if you get I cube, then you use whatever, then you'll give it as like negative I and all that, right? The powers of I. And then make sure you combine the like terms. Now to divide complex numbers, you would first write them in fraction form and then rationalize the denominator. Remember, just like what we did with the radical sign in the denominator of a rational equation. Then that was in 5.1, right? And remember, to rationalize the denominator, we're going to multiply the top and the bottom by the conjugate of the complex number in the denominator. So the conjugate essentially would be the opposite sign of the imaginary number. So for example, if our original is like 3 plus I, all right, that means my conjugate is going to be 3 minus 2I. See how the sign changes for the imaginary number? That will be the conjugate. All right, now let's look at these practice questions. All right, so we have 5 minus 2I plus 7 plus 3I. First thing I'm going to do is group the like terms together. So we have 5 plus 7 minus 2I plus 3I, right? So 5 plus 7 is going to give us 12, and then negative 2I plus 3I is going to give us plus I. And that'll be our answer. Yeah, so as you can see, we want to group the real numbers and the imaginary numbers separately, right? Because real numbers are one group and imaginary numbers are another group. Now, let's do the bottom one where we have to subtract. Remember, be cautious of the minus sign, okay? So we have 10 minus 7i minus 9 plus 5i. So I'm going to open my parentheses first, and as I open it, I'm going to group the like terms together. So we have 10 minus 9 minus 7i minus 5i. Okay, now we group the like terms together. We have 10 minus 9, which gives us 1. Negative 7i minus 5i is going to give us negative 12i. All right, and then that will be the final answer. Now on to multiplying complex numbers. Again, you want to treat them like binomials and use FOIL. All right. So for the first question, let's look. We're going to do negative 6i times 2, which is going to give us negative 12i. All right, and then negative 6i times negative 3i is going to give us positive 18i squared. Now we're not done yet because, again, because of the powers of I, we know what I squared can become, right? So I'm going to do negative 12i plus 18 times negative 1. And then from here, I'm going to get negative 12i minus 18, and that will be my final answer. Okay. Now for this one, we again are going to FOIL it like how we would with any of our polynomials. Okay, so we will first do 5 times 5, which would give us 25. And then 5 times negative 2i is going to give us negative 10i. 2i times 5 is going to give us positive 10i. And then 2i times negative 2i is going to give us negative 4i squared. Okay, now let's group the like terms. So we're going to get 25 minus 4i squared. And again, because I know what I squared can become, I'm going to simplify it. So we have 25 minus 4 times negative 1, which would then give us 25 plus 4 to finally give us 29 as our final answer. All right. If you have any questions about this, bring it to your deep dive lesson. All right, now on to dividing with complex numbers. So remember, we want to rationalize the denominator by multiplying it with this conjugate. So our setup essentially will look like this. Let me rewrite the question. All right, so that means because my imaginary number is here, that means I want to change the sign from negative to positive to get the conjugate. All right. So that means I need to multiply the top and bottom with 2 plus 3i. Okay. Now from here, once I multiply 1 over 2 minus 3i with 2 plus 3i on the top and bottom, I am going to get 2 plus 3i over 4 minus 9i squared. Okay? And then from here, because I know what I squared can become, so I am going to simplify that. Can you see that? There we go. Because I squared is equivalent to -1, so I'm going to replace I squared with -1. Then we're going to group the like terms. Let's see, we got 4 plus 9. And then this will finally give us our answer as 2 plus 3i over 13. And now if we want to write it as a in standard form, remember, which is a plus bi, I would just separate these into two fractions, right? So we're going to get 2 over 13 plus 3 over 13i, and that will be my final answer. Alrighty, that is the end of our pre-lesson video on imaginary and complex numbers. If you have any questions about any of this, again, as usual, bring it to your deep dive lesson or shoot me an email. Alright, have a good rest of your day.